Next we'll come on to chapter 10, which is Trig identity and equations. This is where it's going to get a little bit more awkward because we're going to teach the start of this chapter a completely different way to the textbook. So I wouldn't really pay too much attention to exercise 10a. What I'm going to do though is just firstly explain to you how the sine graph and cos graph are formed. You'll have to excuse my dodgy sine graph, it's very, very poor. Well, it comes from what's called the unit circle. So you've got xy axes and a circle with the centre with radius 1. And then if we imagine this line here, which is a radius of 1, and then the angle theta, where you've got x is the horizontal distance, y is its height. Well, from basic trigonometry, we know that sine theta is opposite over hypotenuse, which equals y over 1. Effectively, sine theta is y. So that means sine theta, the ratio, is simply as this angle is formed, it's the height it makes in the unit circle. So we know, for example, sine 30 is 0.5. So when that's 30 degrees, that's at a height of 0.5. And as it goes up and up and up, when it's 90, sine of 90 is 1. Sine of 180, minus 1, and so on. What would be 0. Sine of 270 all the way around would be minus 1. Similarly for cos, as this line goes around the circle, the cosine of the angle is this horizontal distance here. So those values are plotted to form this graph. I'm just going to show you now how you'd use that graph to work out other angles. Remember, the calculator is always programmed to give you the acute angle. Now, as we've mentioned in the last chapter, a sine graph has a period of 360 degrees. So that means it repeats itself every 360 degrees from 1 to minus 1. Now, in that period, if you were to draw a horizontal line, you will see, apart from the very top and the bottom, you'll always hit the curve twice. So in any period, you're always going to have two angles. They have the equivalent trig ratio, equivalent sine ratio, equivalent value on the y-axis. Apart from sine 90 is 1, sine 270 is minus 1, the two endpoints. And then because it's got a period of 360 degrees, every 360 degrees those angles are repeated. So say, for example, if this is, I don't know, 20 degrees, that's going to be repeated over here, 20 degrees in from 360, so 380. So once you've found two angles in a period, you can work out an infinite number of angles with the same y value simply by adding and subtracting multiples of 360. So say this value here, say it's 0.7, I'm going to get these two angles, add 360 here, add 360 here, take 360 here, take 360 here, and you keep adding multiples of 360 to get all the values that work. So unless it's a ratio that you know, like sine 30 is a half, let's for example do 0.7. Say you want to work out sine theta is 0.7, theta equals sine inverse 0.7, theta equals, so you'd use your calculator to work that out. It's going to be around, I don't know, let's just say, no. 44.4 degrees. Right, so then if we want to work out this angle here, if it's 44.4 degrees in from 0, it's going to be 44.4 degrees back from 180. In other words, just take away from 180. $135.6. So that gives you the two angles of the ratio of 0.7 in between 0 and 360. But if you've got a different domain, say you wanted to work out what angles work between 360 and 540, And then all you do is add 360 to these two angles. So plus 360 to this one is going to be 404.4, plus 360 onto this one is going to be 495.6. So that angle there is 404.4, that angle there is 495.6. Same here, if you wanted these two angles, you just take away 360 to get this one, take away 360 to get this one. So the process for a sine graph is to use your calculator to work the acute angle, take away from 180 to work out the obtuse angle, and then add and subtract multiples of 360 to work out all other angles. But it's also got symmetry properties on this part of the curve here. So, for example, we said 0.7 is 44.4. Well, that means minus 0.7 is going to be minus 44.4. So, if it takes 44.4 degrees to go 0.7 up, it's going to be 44.4 degrees back to go 0.7 down. So, symmetry properties you can use there too. Okay, so things you need to remember then. So we know that sine theta is sine 180 minus theta. So that's going to give you, the calculator's going to give you the acute angle, take away from 180 to get the obtuse, and then add and subtract multiple 360 to look at every angle that works. The cosine graph is actually a little bit easier, because though it doesn't look like it from my dodgy graph, it's perfectly symmetrical about the y-axis. So say, for example, 70 degrees, that's going to be exactly the same as minus 70 degrees. So we can say that cos theta equals cos minus theta. In the same way as what I was describing here, you could say sine theta is minus sine minus theta. So there's a couple of important rules to remember. On a cosine graph though, if we look at our period between 0 and 360 and we go for 70 again, well 70 from the peak is going to be the same as 70 back from that peak. So whereas you took away from 180 on a sine graph, you're going to take away from 360 on a cosine graph. So your calculator's going to give you the acute angle, or an angle less than 180, and then you take away 360 to get the angle on the other side of between 180 and 360. Okay, so we can say cos theta equals cos 360 minus theta. So, for example, with 70 degrees, got an angle here. So 70 back from 360 is going to be 290. So we've got 70, 290. You could also do it from here, from 90 to 70 is 20 back. So from here is 24, 290. So you could do 20 back from there, 430, or 70 on from the peak. 360 plus 70 is 430. But anyway, once you've got these two angles, you can work out all other angles by adding and subtracting 360. So 70 plus 360 is 430, plus 360 will get you that angle. And yeah, you only really need to do it for the positive side, because I know minus 70 is going to work, minus 290 is going to work, minus 430 is going to work, because it's perfectly symmetrical about the y-axis. On a tan graph is the easiest of the lot, because in a tan graph has a period of 180 degrees, but in any period you've only got one angle that works. So your calculator's going to give you the first angle, then to work out all other angles that work, you just simply add and subtract multiples of 180. Let's say, I don't know, what you do tan 0.5, say. So tan inverse 0.5, 26.6. Look like it with a dodgy diagram. But then to work out this angle, all I do is add 180 on. So another 0.5 is going to be 206.6. This one here, take away 180. So what's that, minus 153.4. So Really easy. Use your calculator to work out one angle and then add and subtract multiples of 180. Whereas sine and cosine, we've got a period of 360. Add and subtract multiples of 360. Okay, what you can do now is have a go at a couple of questions of exercise 10a. You could have a go at question 3, for example. So question 3 just gives you some practice on using your sine and cosine graphs. Like question 3a says to work out sine minus 90. Well, you take your sine graph, there's minus 90, so it's minus 1. Sine 450. Well, what you can do with something like sine 450, you bring it down, make it a bit smaller. So if I take away 360, I know that's going to be the same as sine 90. Sine 90 is 1. Okay, so if you've got an angle that's bigger than 360, or negative, so if it's bigger than 360, take away 360 or multiples 360 and 2, you've got an angle that's between 0 and 360. If it's negative, you can add multiples of 360 and 2, you get again an angle between 0 and 360, and then just use your graph to work it out. You can also look at question 4, and that is, it gives you an angle and asks you to work out the acute value. So the first one is sine 240. Sine 240, well, that's going to be, okay, so sine 240 is going to be here. So it's 60 degrees in from here. So it's actually going to be negative value. So the acute angle that's going to work is going to be minus 60. So it's going to be the same as sine minus 60. Okay, let's have a go at those two.